Welcome, grade 10s. Today we're going to learn about Euclidean geometry. It's going to be very interesting to learn this topic. It's one of the most fundamental topics in mathematics. Most mathematics topics, they rest upon this topic because it spans all mathematics in general. So, as we are learning this topic of mathematics, we're going to enjoy doing logical reasoning. It's very important. So the person that you're looking at there is Euclid, right? So the picture that you see there is a picture of Euclid. And yeah, so geometry is a Greek word. It means you have geo means earth and metria means measure, and it arose as a field of knowledge dealing with spatial relationships. Euclidean geometry deals with space and shape using a system of logical deductions. Long before modern mathematics, Euclid around 300 BCE, organized geometry into a logical system in his famous book, The Elements. So the book that he wrote is called The Elements. This is the book that Euclid wrote, and The Elements. And in that book, he was showing that mathematics is built on proof and not guessing. But he wasn't alone. There were other thinkers like Pythagoras, who you know from earlier grades because you learned about the Pythagoras theorem, right? And then Pythagoras explored the number and shape relationships and right angle triangles, etc. And then we also have Thales of Miletus. So we have Thales of Miletus. Thales of Miletus introduced early geometric reasoning. And then later we have René Descartes. Now, René Descartes was a French philosopher and a mathematician. René Descartes connected geometry and algebra. So we'll explore more about René Descartes when we do analytical geometry. Analytical geometry connects algebra and geometry. Yeah. Now, let's get into it. We have the definition of an angle. The definition of an angle is that an angle is formed when two straight lines meet at a point, also known as a vertex. So this is a vertex right here, right? So we got a vertex. So we have a vertex. A vertex is where two straight lines basically meet, right? So where they meet is called a vertex. So if we check here, this will be my vertex right here. This here is our vertex, right? This here is the vertex. Then if I call the point here to be point A, and then this is point C, and this is point B, right? Then I have what? I have an angle here, and then this will be my angle. Then how do we describe these angles? We use different notations. So the angle at A can be written as angle A, or we can write it as angle A, and we can also describe it as angle BAC, or we can write it as angle BAC like this. And also the notation of using Dre letters is basically based on describing an angle in a triangle. For example, I can think of BAC as saying angle at A in triangle ABC. So angle at A in triangle ABC. Let's say I want to describe this angle here, which is angle B. How am I going to do that? I'm going to say angle B, or I can say what? Angle ABC. This means I'm saying what? Angle at B in triangle ABC. So that's what I'm saying basically. And if I want to describe the other angle, which is this angle, I can say what? Angle C, or I can say angle ACB, which is another way of saying angle at C in triangle ABC. So this is how we basically describe these angles using Dre letters. You can think of that as a triangle, and then you are able to identify the angle easily when you think of it in terms of triangles. Then now, angles, we can have a situation where we describe angles. For example, I have angle A here. I can have angle A. This can be my angle A. This is angle B, this is C, and then this is D. Just put, so I have these angles right here. So notationally, I can just write this is angle A, angle B, angle C, and angle D. So putting the head at the top means I'm referring to what? Angles. So the head just shows me that what I'm referring to here are angles, right? Then next we have the definition of an acute angle, right? So an acute angle is an angle that is between 0 and 90 degrees. It's very important to note. So an acute angle is an angle between 0 and 90 degrees, right? So it's an angle between 0 degrees and 90 degrees. And then an acute angle, examples, we can have 30 degrees, 45 degrees, 10 degrees, 39 degrees, 89 degrees, etc. All those angles are acute angles, right? Then we can have the same situation where we have A here, we have B here, we have C, we have D, and then we have this angle, we have that angle, we have this angle, and then we have this angle right here, right? So yeah, so in this case, for example, in terms of measurements, we can, if this angle here, A, and we have, let's say we have what? We have 30 degrees here, we have 30 degrees here, and then we have 150 there, we also have 150 here. So our acute angles here will be A and C. So A and C will be our acute angle. So in this case, this and this, A and C, are acute angles. So that's it. And then we have the definition of a right angle. The definition of a right angle is that a right angle is angle that is equal to 90. We can see that in a right angle triangle where I have A, B, C. And then the angle that is at B, the right angle, which is 90 degrees. We can also write it as angle ABC equals to 90 degrees. So this is a right angle. And then we can also have the definition of an obtuse angle. An obtuse angle is an angle that is between 90 degrees and 180 degrees, right? Then with an obtuse angle, the same principle will apply. We have angle A here, we have angle B, we have angle C, then we have angle D. Now, here, I'll still use 30 degrees, 150 degrees, 30 degrees, and then 150 degrees. An acute and obtuse angle examples can be all angles that are between 90 and 180. We can have 100 degrees, we can have 101 degrees, we can have 150 degrees, we can have 170, we can have 179 degrees, etc. All these are obtuse angles. So in this case, our obtuse angle will be what and what? It will be this angle here and this angle here. So angle B and angle D are what? They are obtuse angles. So these are our obtuse angles. Hope it makes sense. And then we go to the next. We have the definition of a straight line, a straight angle. A straight angle is an angle that is equal to 180. And then we have the same situation. We'll have angle A here, we have angle B, we have angle C, we have angle D. Then the angle at A, I'll call it that it's 30 degrees again, and here it's 150. And then here it's 30 degrees, and here it's 150. Now these lines here, you see we have a single line here, we have a single curve. It means the angles are equal. The two curves that side and the two curves this side means this angle and this angle are equal. That's what the symbols mean. When we have same lines, same curves, it means the angles are the same. So 30 and 30, both of them, they have a single curve. 150 degrees, which is B and D, they both have a double curve. That means they are the same, they are equal. So don't be confused by the symbols. And then now, a straight angle, it's an angle that is equal to 180. So we're going to identify all the straight angles that will give us 180 degrees. The first part, we have what? We have this portion here. Angle A plus angle B. When we add them, we get 180. These are angles on a straight line. And then another portion that we see that it will give us 180 is angle B and C, or C plus D. So angle C plus angle D is 30 plus 150, which will also give us 180. Is also angles on a straight line. Another pair of angles that can give us 180 is what? Angle C plus B is also 180, and then also angle A plus D equals to 180. So those are the straight angles. So all of them are straight angles. And then the definition of a reflex angle is that it's an angle that is between 180 and 360. Examples include 100 degrees, 190, and then we can have 200 degrees, 300 degrees. No, 100 degrees is not, this one is not correct. It's 190, 200, 300, and we can have what? 350, etc. So all angles that are between 180 and 360, all of them are reflex angles. So here it's a mistake. It was supposed to be angle, not angel. So yeah, so we have the same situation. We can have A here is 30 degrees, and then we have B, it's 150, and then we have C is 30 degrees, and then we have angle D is 150 degrees. And then we want to identify reflex angles. So to get a reflex angle, we need to get an angle that is between 180 and 360. So to do that, we basically have to have something. If we add angle A, these angles A, angle A plus angle B plus angle C, they will give us what value? We have 30 degrees plus 150 plus 30. 30 plus 150 is 180. 180 plus 30 is 210, which is reflex. So it's a reflex angle. You see, I can form a reflex angle by adding what pair again? If I add another pair of angles that can give me a reflex angle, it can be what? Can add angle ADC. I'll also have a reflex angle. So if I say angle A plus angle D plus angle C, I'll have angle A is 30 degrees, angle D is 150 degrees, and angle C is 30. And then I'll have the same value of 210, which is reflex. So a reflex angle is an angle that is between 180 and 360 degrees. It's very important. So that's the definition of a reflex angle. And then we have the definition of adjacent angles. What are adjacent angles? Adjacent angles are angles that share a vertex and a common side, right? So here we have a vertex. We have a vertex here, right? Now, that vertex now, we still have the same situation where we have angle A, angle B, angle C, and angle D. So this is my angle A, this is my angle B, angle C, and angle D. Now, we need to identify pairs of adjacent angles, right? We need to identify pairs of adjacent angles. Pairs of adjacent angles. A and D are adjacent angles. So I can choose the pair A and D. They share a common side. Do you see the common side? This is the common side that they share. So A and D are adjacent. Another pair of adjacent angles that you see is what? It's angle C and D. So if you look at C and D, they share a common side, right? C and D are also adjacent angles. Do you see another pair of adjacent angles? Yes. Another pair of adjacent angles that I see is this. They are also a pair of adjacent angles. They share what? A common side. You see? So it means C and B are adjacent angles. Etc. So those are adjacent angles. So we can have other pairs. A and B are also adjacent angles, right? Because they share a common side, that side, as you can see, and a vertex. So that's the definition of adjacent. And then we have the definition of vertically opposite angles. And it says that angles opposite each other when two lines intersect. They share a vertex and are equal. So the statement that you must remember about vertically opposite angles is that vertically opposite angles are equal. It's very important. Vertically opposite angles are equal. And what you need to remember is that vertically opposite angles are equal. Then we can have the same situation where we have angle A here, then we have angle B, we have angle C, then we have angle D. And this is where now these curves will now make sense, right? So according to the definition of vertically opposite angles is that when two straight lines cross each other, they form angles, and the opposite angles that are formed, they are called vertically opposite angles. In this case, we have this pair, we have B, angle B, and angle D. They are vertically opposite angles. So B and D are vertically opposite angles. And they're equal. And then another pair of vertically opposite angles is what? We have this pair here, which is angle C and D. So C and D, angle C, no, which is angle C and A, sorry. Angle C and A are vertically opposite angles. And they are equal. So that's the definition of vertically opposite. Means the angles are equal. Then I can put those angles and then put 30 degrees here, 150, 30, and 150. So we see the vertically opposite angles are equal. They are both 150. In this case, they are both 30 degrees. And then the definition of supplementary angles. Supplementary angles are two angles that add up to 180 degrees. So you can have same situation, angle A, angle B, angle C, angle D, where you have this situation. So a pair of supplementary angles in this case are all the angles that when we add we get 180. So in this case the supplementary angles will be what? The angles on a straight line. So in this case, angles on a straight line are supplementary, right? And then we can write those pairs. We have this pair, angle A plus angle B equals 180. They are supplementary angles, right? They are on a straight line. And then we have angle D, C plus D is also 180 degrees, right? And then we also have angle A plus angle D, and then we have angle C plus angle B is equals to 180. So all these, they are supplementary. They are angles on a straight line. So what this tells us is that angles on a straight line are supplementary. So angles on a straight line are supplementary. That's what we learned from this. And then the definition of complementary angles. Complementary angles are two angles that add up to 90 degrees, right? So two angles that add up to 90 degrees. We draw a right angle triangle, and then we have 90 degrees here, and then we have A, B, C, and then we have 30 degrees and you have 60 degrees. Now if you say angle A plus angle C, angle A is 30 degrees and angle C is 60 degrees. When you add them you get what? 90 degrees. So therefore what does this tell us? It tells us that 30 and 60 are complementary angles. Because when we add them, we get 90 degrees. So other pairs of complementary angles can be what? 10 and 80 degrees. We can have what? 50 degrees and 40 degrees, etc. So 10 plus 80 is 90, 50 plus 40 is 90. So they are complementary angles. And then we have the definition of a revolution. A revolution is the sum of angles around a point and they add up to 360 degrees. Then we have the same situation. We have angle A, we have angle B, we have C, we have D. This must angle A, angle C, angle B, angle D. So a revolution means it's angles around the point. This is the point you are referring to. Now, if we add, we have 30 degrees here, we have 30 degrees here, we have 150 there, we have 150 there. If we say angle A plus angle B plus angle C plus angle D, then 30, angle A is 30, angle B is 150, angle C is 30, angle D is 150. 30 plus 150 will give us 180. Also 30 plus 150 is 180. 180 plus 180 is 360 degrees. That means angles around a point, they add up to 360 degrees, and we call that revolution. Hope it makes sense. Then parallel lines and transverse lines. The definition of intersecting lines. Two lines intersect if they cross each other at a point, right? Now, if you look at the diagram here, we have the diagram of two parallel lines. The lines that are parallel here, AB is parallel to CD. Now, when you see the symbol, this symbol, it means parallel. And then other lines that are parallel is what and what? MN is parallel to OP. MN is parallel to OP, right? And then we have, I will also state that they refer to the symbols, they mean parallel, as you learned in earlier grades, right? And then the intersecting lines, you can see where the lines intersect, right? So if I look at line here, so MN and AB, line MN and line AB and line MN, they intersect at this point. So this is the intersection, right? And then another, so those lines, they intersect. Then if I say line DC and line OP, where do they intersect? Line DC and line OP. So this is line DC and then this is line OP. They intersect. This is where they meet. So this is the intersection. See, that's where they meet. So they intersect, two lines intersect if they cross each other at a point. And then we have the definition of a transversal. A definition of a transversal is that a transversal is a line that intersects two or more parallel lines. And then if we look at the diagram in the next page, we have a transversal here, right? A transversal in this case, it's EF. So it's a line that passes through, it cuts through two parallel lines. So our transversal is EF. So EF is a transversal. Then we know that AB is parallel to CD. It's given, right? So the parallel lines, this line and this line, they are parallel. And then we can talk about interior angles, the definition of interior angles. Now, interior angles are angles that lie in between the parallel lines, right? The angles that lie in between the parallel lines, if we identify them here, is this angle A. So angle A. And then we also have angle B. They lie in between the parallel lines and they are basically inside. You can think it this way. You have this section. So the angles that we are referring to, they are all lying inside this section, right? So angle A and angle A, angle B, angle C, angle D, and angle C. Do you see that they are all lying within this section? They are all between these parallel lines, inside and between these parallel lines. So that's what the definition is saying. So these are interior angles. So our interior angles are angle A, B, C, D. Yeah, the interior angles that lie between parallel lines. And then the definition of exterior angles. Exterior angles are angles that lie outside the parallel lines. Now we are referring to this region. So in this case, we are referring to this section outside the parallel lines. You see? Now, all the angles that are outside the parallel lines are these angles. It's angle H and G. So this angle here and this angle here, and then we have E and F. So angle H, angle G, angle E, angle F, these are the exterior angles outside the parallel lines. Outside the parallel lines. And then we have corresponding angles. And corresponding angles, they form an F shape, which comes in different forms. It can come in this form, it can come in this form, yeah, but it will always be an F shape. And then how do we identify corresponding angles? So this is how we identify corresponding angles. We just look for an F shape. So let's draw an F shape. So this is the first F shape that I'm seeing. So this is the F shape. And then we know on the F shape, these angles are corresponding. So in this case, you can see that the corresponding angle here, it will be what? B and F. So angle B and angle F are corresponding angles. And then another pair of corresponding angles that I see, I'm gonna draw the letter F again. We have this, another letter F. And then this letter F is in this form. So we have corresponding. So it will be what angle at what angle? Angle A and angle E. So this is angle E here, that angle A. So angle A and angle E are corresponding angles. And do you see another letter F? Yes, there's another letter F. Can draw it in blue. So we have this other letter F that we can draw in this format, right? Then here we have angle C, here we have angle G. Then if you draw it, you basically have this situation. So angle C and G are corresponding angles. And then another letter that we see, another letter F that we see is this one, where we have this, and then here we have angle D, and then here we have angle H. Then the letter F is in this form, a pair of corresponding angles will be this, and then you can say angle D and angle H are corresponding angles. So that's how we identify corresponding angles. We just look for the letter F, right? And also the definition tells us if the lines are parallel, then the corresponding angles are what? They are equal. So then it means that because of here we have AB is parallel to CD, means the corresponding angles are equal, right? So it means angle B is equals to angle F, and angle D equals to angle H, and then angle C equals to angle G, and then angle A equals to angle E. If AB is parallel to CD, then the corresponding angles are equal. Very important. So when lines are parallel, the corresponding angles that are formed will be equal. Don't forget that. And then the definition of co-interior angles. These are angles that lie in between the lines and on the same side of the transversal. If the lines are parallel, the angles are supplementary. They form a C shape. Then these are the co-interior angles. You're gonna look for a C shape. Now if you check here, I have the first C shape here. This is my first C shape, is in this form. This is the co-interior angles. And if I identify them there, it's angle C and angle B are co-interior. It means, and then we also know that AB is parallel to CD. So since AB is parallel to CD, then C plus B equals to 1/8. They are supplementary. Whenever the lines are parallel. And then another C shape that I see is this, right? And then this will be my pair of corresponding of my pair of co-interior angles, sorry. And then I'll have this pair of co-interior angles. And then in this case is angle A. Here is angle A and angle D. So angle A and angle D are co-interior angles. We check the alternate angles. So alternate angles, they form a Z shape, right? So if we check here, the first Z shape that I'm seeing is this shape here. And then these are the alternate angles. And the lines are parallel. AB is parallel to CD. And then the alternate angles are what? Angle A and angle C. Since AB is parallel to CD, then angle A is equals to angle C. So these are the alternate angles. So the alternate angles are equal when the lines that are parallel when lines are parallel. So the lines that are parallel that form the alternate angles, they cause those alternate angles to be equal. And then The next Z that I see is this one. You see, that is the other Z that I'm seeing. This is the shape. This angle and this angle are alternate. It's angle B and angle D are alternate angles. And since AB is parallel to CD, then angle B is equals to angle D. So again, parallel lines cause alternate angles that are formed to be equal. So that's the situation here. And then we have a remark here for proving that lines are parallel. So let's say you want to prove that lines are parallel. So the remark says that if two lines are intersected by a transversal such that the corresponding angles are equal, or the alternate angles are equal, or the co-interior angles are supplementary, then you can make a conclusion that the lines are parallel. For example, let's say I have two lines, line AB and line CD, and then there's a transversal, this line here, that is passing through both of them. If I know that the angle that is here is 40 degrees and the angle here is also 40, therefore I can say AB is parallel to CD. That's what the statement is saying here. So if you find that if two lines are intersected by a transversal, here is the transversal, this is the transversal, such that the corresponding angles are equal, or the alternate angles are equal, or the co-interior angles are supplementary, then the lines are parallel. In this case, I use the example of alternate interior angles. So in this case, the alternate interior angles are equal, so we can make a conclusion that what? Line AB and line CD are parallel. So that's how we prove that the lines are parallel, using these three conditions. Then let's look at this example to brush our skills. So we have a problem here. Example 1, it says find all the unknown angles and determine whether line EF is parallel to line CG, and give reasons for your answers. 1.1 says find X. So here we are looking for angle X. So how do we find angle X? Then we check. If we look at angle X, we can see a Z shape. We are given that line AB is parallel to line CD. So if you look at this, there is a Z shape and the lines are parallel. This is the Z shape. So it means the alternate angles here is this angle and this angle. So therefore, we're gonna start by saying AB is parallel to CD. And then after saying that, then we say angle X is equals to 60 degrees. And then our reason will be alternate angles. And this is because of AB is parallel to CD. So that's how we find our angle X. And then 1.2, find Y. Find Y. And then to here, to find Y, we're gonna say if we look at Y, the value of Y. So here we have 60, right? Here it's 60 degrees. Now we want Y. So how can we find Y? Now if you look at Y, it forms a C shape. So if this is the C shape I'm referring to, it means this angle and this angle, they are co-interior. So when we add them, we get what? 180. So y plus angle y plus 160 degrees is equals to 180 degrees. These are co-interior angles, and then angle y is equals to 180 degrees minus 160, and then angle y is equals to 20 degrees. And then when we write the reasons here, we must also state that the lines are parallel. Because of co-interior angles to be equal, the lines need to be parallel. And then we have 1.3, we are looking for P. So now we have found our y is 20 degrees is here. And then now we want the value of angle P. And then angle P forms a vertically opposite angle with angle y, as you can see. So we have this situation, this angle P. So we have this situation, we have y, we have P. So we can say angle P equals to angle y. Reason, vertically opposite angles. And we just learned that vertically opposite angles are what? They are equal. So therefore angle P is equals to 20 degrees, because the value of y is what? Is 20 degrees. And then now we want to find angle R, right? Then if we look at angle R, we just found angle P, right? Now we want to find angle R. So how can we find angle R? Angle R forms an F shape. So if I draw the shape like this will be my 160 degrees, and we know this line and this line are parallel, right? And this is where the angle R is. Do you see that these are corresponding angles? So it means angle R is equals to 160 degrees, and then the reason will be corresponding angles. And then this is because of line AB is parallel to line CD, right? And then that's how we will determine it. And then now we want to find angle S. Now if you look at angle S, you have this situation. You have 90 degrees given, you have angle X, which we determined, and then we have angle S here. Angle X, we calculated it, we find it to be 60. Now if you look at these angles, they all lie on the same straight line. Do you see? Now what did we say about angles on a straight line? They are supplementary, or they equal to 180. So angle S plus angle X plus C plus 90 degrees is equals to 180 degrees angles on a straight line. Therefore angle S plus 60 degrees plus 90 degrees is equals to 180 degrees. Angle S plus 60 plus 90 is 150 equals to 180, and then angle S is equals to 180 degrees minus 150. Therefore angle S is equals to 30 degrees. And then that was 1.5, and then 1.6 is line EF parallel to CG. So now we want to know if line EF is parallel to CG. So then now I'm gonna draw the diagram. So we have this diagram here. So line EF is parallel to CG. So that's what we're looking for, to CG. So this is my C, and then this is EF. Here we have 160, and then here we have Y, we have R, here we have S. And then the value of Y is 20 degrees, right? And then the value of S that we calculated is 30. So do you see that they form a Z shape? So we have E, F, and then we have what? We have 20 degrees here. And then here we have 30 degrees is CG. So because of these are alternate angles, right? So it means S and Y are alternate. But they are not equal. Therefore, EF is not parallel to CG. I hope it makes sense. So this is how we determine. So next time we'll continue with this Euclidean geometry. Bye for now.